Hi everybody, Justin here from chemistrynotes.com, and this is our third video on section 10, liquids, solids, and intermolecular forces. Today I'm going to talk about the liquid state, just an overview of it. We're going to talk about three particular qualities of a liquid that are influenced by how strong that liquid's intermolecular forces are. Okay? Stronger the intermolecular forces, the stronger all three of these guys are going to be. And by guys, I mean surface tension, capillary action, and viscosity. All right, so the liquid state, an overview. Water is the most abundant liquid. That's fairly straightforward. Most of us would know that. Water is a fluid, of course. If it's a liquid, it's a fluid. Gases are also fluids, by the way. So liquids vary greatly in three particular areas. All right? And they're all influenced by intermolecular forces. 1, surface tension. 2, their ability to exhibit capillary action. And 3, viscosity. So let's talk about 1, 2, and 3 in order. They're all very closely related in the fact that the stronger the intermolecular forces are, the greater its surface tension, the greater its viscosity, and the more difficult it's going to be to exhibit capillary action. So, number 1, surface tension. This is the resistance of a liquid to an increase in its surface area. The greater the intermolecular forces, the greater the surface tension is going to be. And let's kind of show a visual of why that is. So what I'm drawing there is water beating on the waxy hood of a car. So each of those little circles would be a water molecule, and the forces that are keeping it together like this is the fact that water is trying to minimize the amount of molecules exposed to the hood surface. So to do that, all the water molecules kind of beat up above, right? Beat up above like that. And that increases the amount of interactions between water molecules, right? Hydrogen bonding. And it also minimizes the amount of interactions between the water molecules that are directly on the hood of the car, interacting with that hood surface. So what does it say there in that little bracket? It says water molecules prefer to interact with each other while minimizing interactions with the car's hood. And the last statement here before we move on to capillary action, liquids with large intermolecular forces will have high surface tension, and examples of that are going to be polar molecules. So liquids with large intermolecular forces, such as really big molecules, right? LDF forces can add up for those guys. And polar molecules, they are going to have high surface tensions. Number 2, we got three to talk about, right? Surface tension is done. Now we have capillary action, and after that we're going to do viscosity. Capillary action really is a battle between two specific forces, adhesive forces and cohesive forces. But before we get into what cohesive forces are and what adhesive forces are, I'm going to give you two definitions of capillary action. I like the second definition better. Capillary action, the spontaneous rising of a liquid in a narrow tube. And the second definition for capillary action is the ability of a liquid to flow against gravity up a narrow tube due to adhesive and cohesive forces. All right. So the adhesive forces are the ones that are trying to pull the water up via the sides of the tube. The cohesive forces, those are the ones that are going to want to those are interactions between the molecules of the liquid themselves. So let's get into these two forces involved. The first one, cohesive forces. These are the intermolecular forces, and I've written IMFs just to remind you of the abbreviation. The intermolecular forces among the molecules in the liquid sample. So this is just regular intermolecular forces between the molecules of a liquid sample. Adhesive forces, this is the attractive force between the molecules of the liquid sample and the molecules that make up the surface of the narrow tube. Okay, so if it's a graduated cylinder in a lab class, it could be either plastic, it could be glass, right? Then those are just two examples. So cohesive forces, the intermolecular forces among the molecules in the liquid. Adhesive forces, the attractive forces between the molecules of the liquid and the surface of the tube. All right, finally, number 3, viscosity. Viscosity is the resistance of a liquid to flowing. Think of sap on a tree, right? Sap really doesn't want to flow down that tree. It takes sometimes years to flow, sap. Viscosity, sap is very viscous. Viscosity, the resistance of a liquid to flowing because of strong intermolecular forces. Maple syrup, very viscous. I got one more bullet point to make here on viscosity before we introduce two very general types of solids. Viscosity is greater in substances with stronger intermolecular forces. Just think about that, right? Viscosity is greater in substances with stronger intermolecular forces. Sap on a tree, maple syrup on a pancake. These guys are not flowing very well. Well, then those guys must have very high intermolecular forces keeping the molecules together as opposed to flowing. So viscosity is greater in substances with stronger intermolecular forces because molecules are more strongly attracted to each other as opposed to the tree or the next area on the pancake that would help it flow. Okay, so it prevents them from freely flowing around each other. All right, so switching gears now. Just want to introduce solids real quick. I'm going to talk about solids now in section 10. Section 10 is liquids, solids, and intermolecular forces. So we're kind of moving into solids now. There are two very broad classes. So we're going to introduce these two classes of solids today. The first one is amorphous solids. Amorphous doesn't sound very sturdy, does it? That word sounds morph, to morph from one thing to another. It doesn't sound very sturdy. So, and you would be right. It's amorphous solids. It says here they have considerable disorder in their structure. The solid looks or appears inconsistent and irregular at the microscopic level. So there's no consistency in these guys. Examples are glass and plastics. Now I put 3 stars by crystalline solids because these are the ones that are by far more common, and these are the ones that we're going to talk about the most. Crystalline solids, or crystals, are defined as, or described as, solids in which atoms, molecules, or ions are arranged in highly regular and repeating patterns. Highly regular and repeating patterns. They're very ordered. They're very structured. Okay? And I made a little side note here that the crystalline solids are the most abundant by far. So these are the ones that we're going to study the most. So, the top of our last page of today's notes, it says crystalline solids. And I'm just mentioning to you here that we're going to do a very in-depth look starting in the next video. Unit cells, face-centered cubic, body-centered cubic, etc. So if you like the way I do my handwritten general chemistry notes, I have a website, chemistrynotes.com. On that website, I have all my general chemistry notes, and I also have all my organic chemistry notes. So please go take a look at that. And in the meantime, and I'll see you here for the next video soon. All right.